Welcome to today's webinar on helping companies make data centers better. Today's webinar is titled Using High Density Computing and Integrated Data Center Management. My name is Mark Gatos. I'm Chief Marketing Officer at Enlight Software. We'd like to thank you for the time you're going to be spending watching this webinar. We're fortunate today to have two speakers with us. We have Greg Sifferlin, Strategic Account Manager for Data Centers from Carrier Corporation. We also have Jeremy Clute, who's Vice President of Business Development at Enlight Software. If you have any questions for us, please submit them into the chat and we'll try to get to all of them at the end of the webinar. Jeremy, why don't you take it away?
Great, thanks Mark, and thanks everyone for your time today. We're excited to have so many people registered and attending this webinar. And first I'll start with just a bit of an agenda about what we'll talk through. So first we'll do an introduction of integrated data center management for you. And then we're going to talk about rack density and the fact that it is definitely increasing and what are some of the drivers around that. We'll also talk about high density and lights out data centers converging at the edge. We'll get into some really interesting topics around adaptable and scalable cooling. And then we'll show you all the available resources that we've put together for you in various places. So first, the introduction. Data centers have never been more vital or central to business operations, but you need to be ever more efficient, resilient, and flexible. And these imperatives are best addressed by tightly integrating the critical infrastructure. So we're thinking power, cooling, monitoring, and the building itself with IT equipment and applications. These imperatives led Enlight Software, Automated Logic, and Carrier to partner to bring integrated data center management to market. With Automated Logic, you've got the controls and automation, building automation systems. Carrier has excellent HVAC equipment, and they have a very keen focus on the data center market itself. And then Enlight Software provides industry-leading DCIM software for managing your data center and IT space. So integrated data center management, as we've defined it, tightly integrates the different systems within a data center in new and unique ways for energy savings, reduce costs, and improve resiliency. So let's talk about high density computing as a key driver for integrated data center management. A recent survey conducted by the Uptime Institute indicated that 69% of respondents say their average rack power density has increased in just the past year. So we know it's increasing, but why? Well, physical space is at a premium, especially at the edge. Content providers need to minimize latency, so they have to put more computing power closer to their end users. Another example is co-location facilities. Lots of customers are leveraging co-location facilities today, and they need to pack as much computing power into their subscribed space as possible. And so that's another driver. Modern workloads, especially artificial intelligence and machine learning, require more and higher powered chips, more memory, more storage, and you get the idea. More and more assets, right, require that we have to pack more into the same space we're using today. And I'll round it out by saying high density racks are more efficient and manage and cool. And so we'll have really interesting topics for you around the cooling and things we can do with that as well as we get through the presentation. So let's talk a bit about the integration of IT and facilities. 10 years ago in the industry, we were all talking about the gap between IT and facilities in the data center, the fact that this gap needed to be closed. But in practice, there weren't a lot of compelling reasons yet for people to do so. And now that discussion from what was future 10 years ago has become the present today. We are looking at high density computing. We are looking at lights out facilities. And we have to achieve greater efficiencies and higher rack densities. And as rack density increases, operators have to closely align the needs of IT with the capacity of their critical infrastructure, and vice versa. From a high density perspective, capacity is key. So when we look at the capacity of power, cooling, and space in our data center, losing capacity on one or running out of capacity for one is akin to running out of capacity for all. They all must be accounted for, and you can only get a true picture of that by integrating the systems that manage your IT and your facilities. You no longer have the luxury of overbuilding your infrastructure. So we have to be laser focused on what the actual situation is with our capacity to appropriately place these workloads. Now I want to talk about managing lights out data centers. So with lights out, you can be much more efficient, but it's not a panacea yet. If you really think about it, lights out computing allows you to place workloads in an environment where you don't have to be as concerned with things like human comfort, elements like space, temperature, humidity, and so on. So you can obviously be more efficient, but you definitely, with lights out as well as with high density, introduce greater impact of failures. In other words, a problem with one rack, one high density rack, is now a problem with many more IT assets or workloads than before. On the other hand, lights out facilities allow you to be more creative with design aspects. So getting back to space, for instance, if you think about a data hall today, a traditional data hall, you have to look at the way the aisles are, the width of the aisles and the space that is there, in many cases is for the operation with human beings considered in that environment. The same goes for temperature, obviously, but we know the equipment doesn't necessarily need the same level of temperature or ambient temperature, the cooling that a human would require to be comfortable in their job there. So this allows you to be creative with your design aspects. But when you're looking at managing lights out or high density, very thorough and integrated approach to monitoring and management. If you look at the trend of major vendors toward micro data centers, for instance, providing lots of models for flexibility in multiple use cases, it's really important to note that, or to ensure, you need to make sure when you're looking at things like that, that they're being designed with hands-off management in mind, so that it doesn't require lots of human interaction. And then let's talk about, we've already established the need to integrate IT and critical infrastructure management and monitoring systems. Let's talk about some of those reasons. Well, first, risk identification of critical infrastructure failures and their impact on the business. In other words, which workloads downstream from a critical infrastructure failure are going to be affected, and what does it mean to us? You also gain better insight into the types of IT gear in the racks. So thinking back to the example I used at the beginning around artificial intelligence and machine learning, those types of processing units, those types of workloads often require banks of tightly packed GPUs or high process together to perform the workload. And if you don't have the visibility into the racks to know if all those servers are aligned correctly, grouped together correctly, and so on, you run the risk of not being as efficient as you should be. Another good thing about lights out data centers in particular is the reduction of human error failures. A recent survey done by the Ponemon Institute in just January of this year cited failures due to human error, along with cyber attacks, IT equipment failures, and a few UPS failures, among the top 5 reasons or leading causes of outages cited by participants in the study. We've also gained improvements in power and space efficiency, as we just discussed a minute ago around the creative elements of design. And lastly, you get increased visibility into where new or different cooling methods are needed. And hold on to that thought for a second, because we'll come back to it. So what I wanted to do here is illustrate an approach for managing risk of failure in high density computing. And first, I'd like to say that with just a few images, what we've really done is condense a very complex and integrated situation, landscape. So if you think on the left-hand side of the screen, we're looking at a screen from Web Control, leading building automation system. So obviously in the data center, that's managing our critical infrastructure, but it's much more than that. It also integrates our lighting system, our fire suppression system, our security. And then as we trend toward the right, we've got DCIM or supervisory systems like Nlight software. And the integrations are already resident in that realm as well with things like ITSM or ticketing systems, CMDBs and virtual management and so on. So in this example, what I'm thinking is you look at critical infrastructure monitoring. So you're looking at your BAS. It indicates a problem with a piece of critical infrastructure. Let's say it's a large air handler. Air handler's got a problem. Through the integration with your supervisory system, you can tell immediately that you have downstream workloads that are going to be affected by that failure. And those workloads are critical to your business. Once you know what those workloads are, and let's talk about the shape and size of them. In other words, are they running on 20 VMs, on 10 servers, or whatever that is, you can use the predictive analytics in that supervisory system to locate a new and optimal space for processing those workloads to get them out of harm's way. And from there, once you've identified where those critical workloads need to be placed, appropriate workflows can automatically be invoked to take some remediation action, such as automatically, optimizing the cooling system or moving the workloads or what have you. So this is a very powerful story illustrated in just a few simple pictures. Now, we've already talked about in this case, I talk about cooling system optimization, and on the prior slide, I wrapped it up with adaptable and scalable cooling designs. And so with this, I'd like to hand it over to Greg to take us through some of those things. Greg, over to you.
Thank you, Jeremy. Hello, everyone. Data centers on a whole are very large consumers of electricity. Well, that's quite an understatement when you consider that 20 megawatt and 40 megawatt data centers are being commissioned every week. So much so that regulators like the Department of Energy have pressured organizations like ASHRAE to provide guidance to consulting engineers for more efficient data center design. Additionally, some data center operators have taken a very socially proactive approach with sustainability in data center design, to the point of even targeting totally self-sufficient designs relative to power consumption. All in all, data centers have seen very dynamic change with respect to size and makeup. There are significant trends driving that change. Over a span of 10 years, we've seen server inlet temperatures rise from a range of 68 to 72 degrees Fahrenheit to a range of 74 to 78 degrees Fahrenheit. This has enabled us to operate with increasingly higher chill water loop temperatures. At the same time, average rack density has risen from 2 to 3 kilowatts per rack in 2010 to as high as 7.5 to 8 kilowatts per rack today. That's an average. Over that same period, the servers themselves have seen airflow requirements lowered. For delta T purposes, we now see that the average airflow could be 120 CFM per kilowatt versus what it used to be at 160 CFM per kilowatt. So now we have higher density IT loads, meaning more kilowatts per square foot on the white space floor, with those IT loads producing higher discharge temperatures. This all translates into higher return air temperatures at the computer room air handlers. For instance, if we start with a 75 degree Fahrenheit inlet temperature at the server and have a 30 degree Fahrenheit rise, we end up with a 105-degree Fahrenheit return air temperature to the computer room air handler. This all helps drive chill water plant efficiency. Today, we can find typical leaving water temperatures from chillers in the mid-60s. Return air temperatures to the computer room air handlers, typically now 95 to 105 degrees Fahrenheit. And partial free cooling availability with ambient temperatures in the 60s. The pull-in for optimization with all this comes from the integration of the BMS, web control, with the IT software, Nlight, acting as a complete data center system. Next slide, please. So how do we leverage the ambient to maximize the chill water plant efficiency? With the 30XV air-cooled free cooling chiller, we have the ability to drive that efficiency. We just talked about how higher temperatures in the white space allow us to operate with higher chill water loop temperatures. This allows us to maximize available free cooling hours. Further efficiency is gained by integrating the IT cooling demand with the chiller operation and chill water loop temps by both staging compressors and staging chillers to better match the physical plant with the demand on the white space, the actual white space load. We have variable speed compressors and variable speed condenser fans, which can be run better to match the chiller capacity with the load. And we have onboard power monitoring, providing real-time operational feedback to web control to optimize the data center PUE. Next slide, please. So what is the best way to integrate the chiller with the monitoring and the control platforms? We can use web control for adjustments to chill water loop temperature and flow, maximizing the pre-cooling hours. We can use rack temperature monitoring by Nlight to adjust the computer room air handler's fan speed. And we can modulate the chill water valve position on the computer room air handlers with web control. So by using real-time power monitoring at the chillers, we can maximize the chiller operation and better match it to the IT load. Overall, with data center monitoring and controls by web control and Nlight, we can maximize the annualized PUE for any data center. Jeremy?
Thanks, Greg. So now I'll just run through a few summary points. First, high-density computing increases efficiency, but it can also increase the impact of failures with critical infrastructure or IT. Second, integrated data center management reduces risk of outages or breaches due to poor capacity or asset management processes. Data center operators must integrate their IT and critical infrastructure management and monitoring systems to increase efficiency, resiliency, and overall better manage capacity. You can improve resiliency and efficiency by simulating critical infrastructure and software for planning, operations, optimization, and failure scenarios. This is the idea of the digital twin. Probably many of you have heard of that, and being able to effectively digitally represent your physical environment to plan for all of these scenarios is a key item, and is something that as you get closer and closer to your goals, the gains are harder to achieve without planning tools like that. Data center PUE is optimized by matching the cooling requirements of IT loads with the optimal operating point of the chillers and mechanical plant based on outdoor ambient. And real-time monitoring allows the web control and Nlight control platforms to maximize mechanical operation for any given IT cooling demand year-round. We've put together a lot of resources around integrated data center management. We've created videos and webinars. We've published technical papers and even an IDCM for Dummies book. And you can find all of those in our web locations at automatedlogic.com, carrier.com, and nlight.com, all there to the right. And if you want to learn more about any of the things we talked about today, or IDCM in general, or carrier HVAC, please contact your Automated Logic Strategic Accounts Manager or your Enlight Software sales representative. We also have a page of links that will take you to all sorts of frequently asked questions and resources. And we want you to be able to access these. They are all publicly available. So please take a look at those and reach out with any questions you have. And with that, Mark, I'll hand it back to you to see if we've gotten any questions today.
Thank you, Jeremy. We have a few questions. I'm going to submit them and see who would like to take them on. The first question is from Rob. Can you make the data center or some racks too dense?
Thanks, Mark. I'll take that one. And the answer unequivocally is yes. There is such a thing as too dense. And again, when I said capacity is key, this is where that really comes in, right? You have space, you have power, and you have cooling, but you cannot just indiscriminately load racks with equipment to make them highly dense. You will run high risk of running out of power, not being able to adequately cool those assets. So it does take a well thought out design approach, and it does take the integration of your critical systems to make sure that you have the available space, power, and cooling to support your high density computing needs. You may find that you don't, and then you have other options at your disposal to go from there, whether you need to find new space, build new space, or what have you. But absolutely, you cannot just load up a rack to make it a high density rack without knowing all the other factors that go into it.
Okay, thanks for that answer, Jeremy. This might be a good one for you, Greg. This one's from Raj. You talked a bit about savings and efficiency, but where is the bulk of the savings coming from when you take this approach?
Oh, it's a good question, Mark. So without a doubt, if you go back even 10 years ago, there were data centers that there was as much energy for the mechanical cooling as there was for IT draw, what the actual servers were drawing in the data center. So wherever mechanical refrigeration is used to cool data centers, compressorized systems, the bulk of the savings is going to come from keeping the compressors offline or limiting their use for the cooling process. So the more we can utilize the outdoor ambient, in this case to leverage with a free cooling chiller to help cool the data center or remove its heat through economized free cooling, the more we can limit the use of compressors to just trim cooling. Obviously, you need to have the equipment designed to run on the worst case high temperature design day in the summer. But the reality is the majority of the year that we can keep those compressors from running. So by staging, by utilizing free cooling systems, we have the ability to limit the compressor operation, and we can gain tremendous energy savings.
Okay, great. Thanks for that answer, Greg. This one is from Linda, and maybe you want to take this one, Jeremy. Is security a factor in high density computing?
That is a great question, Linda, and security comes up in almost every presentation, so I appreciate the question. Yeah, security is definitely a factor here, and for a few reasons I can think of off the top of my head. First, you need to be cognizant of which workloads are placed next to each other or near each other, right? Do certain assets and data sets need to have distance from one another? I'd also say that not all computing facilities or racks are created equal, and you need to factor that in when you're laying out your workloads. Again, you cannot just indiscriminately place workloads or assets where they would be accessible if they shouldn't be. And lastly, and I would say this, you probably already have metrics in place built around every facet of the data center. I'm sure if it moves, you measure it. But one thing you definitely want to be looking at or consider is risk per workload as a metric. And I would say with that, Mark, I think off the top of my head, those are my security answers.
Thank you, Jeremy. Thanks for that answer. So I think that's all the time we have for questions. I'm going to wrap this up. I want to thank you, Jeremy, and thank you, Greg, for the time you spent with us. Thanks, everyone, for joining this webinar. This is the first in a series of webinars specifically on the topic of making data centers better. We look forward to seeing you on future webinars. And by the way, if you have a suggestion for a topic you'd like us to cover, please feel free to drop an email to info@nlight.com. Thanks again, and we look forward to seeing you on future webinars.